Hi, this is a tutorial on how to use Excel for students of online and on-site schools who are taking statistics courses and are required to turn in their work and are probably people who have never ever seen Excel before or never used Excel before or never used it in this way. So what I'm going to do is give you an option. Many schools will give you the formula for the things that you have to do inside the textbook that you've got. So if you've got a really great textbook like the one I use, which is Briggs, Triola, and Bennett, um, there's a formula on a page and a description, and it tells you what it's all about, and it gives you the tables that you need to evaluate it and all that stuff. But when it comes time to solving the problems for your weekly assignment, it suggests that you use the XLStat plugin for Microsoft Excel spreadsheet, or to use the very complex but very powerful SPSS, which is usually available to students and faculty from schools for for an inexpensive amount or even for free sometimes. Um, there are easier ways to do this. Now, obviously, there's lots of places that you can go on the internet and use a calculator and get a result, and that's a good thing. But it's also a good thing to do what we used to do in the old days, back when there were dinosaurs and no computers and all that stuff. And one time at least, figure out how to use your Excel spreadsheet to do the actual formula. So what you're looking at here is a page that's set up to calculate a single mean t-test. Now a t-test is a statistic that allows you to check whether a mean, so like an average score, from a group of scores that you've got is significantly different from another group of scores. And it can be a group of scores from a second test your people took, that's a dependent mean. It can be from a second group of people, that's an independent mean. Or it can be like this one, a single mean t-test, where you're testing the average score that your people got on a particular test against a population score, meaning a score that either theoretically should be the average, that's the thing you're shooting for, or from, let's say you're working with eighth grade students and you've got the actual mean score on this particular test from thousands of eighth grade students in your country. That would be the population. So the population is everybody, and the sample are the people in your particular classroom or your particular set of scores that you're dealing with. So in this case, your textbook or your data file or your assignment sheet has asked you to do a single mean test score, and you can't quite figure out how to get Excel stats to work, and you really don't want to deal with something so complex as SPSS. So this is something that I recommend. Now, first, if you're new to Excel, you need to know that you're going to be dealing with the cells of the spreadsheet. And the way you figure out what a cell is a cell has a cell address. Along the top of the spreadsheet part, it has columns, and each column has a letter. And down the side, each row has a number. So that's what makes up your cell address. For instance, I have listed my students from 1 to 20. So there's 20 students in this class, and their student number is listed in A column, and they're listed on the rows. So A1 is the address for the first student, and A6 is the address for the sixth student, and so on. Now I'm going to put their scores in B column. And what I'm doing is I'm typing the numbers and I'm using my arrow keys to go down from cell to cell. So I'm entering in the various scores that the students have gotten on a test that has 10 questions, and they can get a score anywhere from 2 to 10. And I'm just entering them all one after the other by typing them into the cell and using the arrow key to go down. Now you can see that what I've got in here is a formula because it's added up the values that are in this column, and I'll show you what that formula looks like. You go up here to the top of your screen, and next to all of this good junk here, you see this big long white bar. And in that white bar, what you will see is the content of each of these cells. So cell B6 is the score of 10. There's the 10. Cell B14, that student also got a 10. And when you come down to X total, which is the total of all of these scores, you'll see that it says 137 in B21. That's the place where the total lives. And up here in the white bar, you'll see the formula that was put in there. It's really important that when you write a formula, you always put an equal sign in front of it because that makes it calculate. So we're going to take the sum. In order to get the total, we are adding up or taking the sum of this whole column. So we'll go right back there. So we have sum, and then the thing that you have to do once you put in sum is you have to name the range of scores. You have to name the range of scores that are listed here that you want to add up. Well, our scores are in cell number B1 all the way down to cell number B20. So that's the range that we put here. So the convention is equals sum, left parenthesis, B1 dot B20, close parenthesis. You'll notice that up in the white bar, it has turned the little period that I put in to a colon. You can stick a colon in if you want, or you can do just a period like I did. So I'm going to come back down here and I'm going to type it again. So it's equal sum, and you'll see there's lots of different kinds of sums there, but we're just using the basic one that adds things up. You start your range with the parentheses, and it shows you the convention underneath. You go from cell 1, where your first score is, to the last score, and mine is B1 to B20 with a period. Close that parenthesis and hit enter, and it gives you the total, and up here shows you your formula. Now you notice while I was doing that, I'm going to do it again, it actually puts a line around the data that you're working on. So you see you've got a nice big old blue box that has encapsulated the data, and then you close it off and it calculates it. If you make a mistake, you'll get an error message that tells you. Now, all I did here for n, if you have a really huge amount of scores, you can do something called count, and you do equal count and then name the range again. But I can just see I have 20 scores, so I wrote 20 in here and didn't worry about it. Now, this is the sample mean. Now, this is where you get the average score for the whole group of scores. And if you look up, down here, it's telling us that the average score is 6.85. And up here at the top in the formula bar, it shows you what the formula was. And basically, it's just taking B21, that's the address of the total number of scores when you add them all up, and you're dividing it by B22, which is the place where the number of scores are. There's another way to do it. So here you see equal B21 divided by B24, and that is to do the average. So you just type equals average, and then you name your range again, B1 to B20, and close it, and that gives you the same thing. So you can do either one. You can take the total divided by the n, so the all of the scores added up divided by the number of scores, or you can use a formula which is equal average B1 to B20. Now, I know, say, from the manual that I got with this test that I gave, that all of the 8th grade students in the United States, the average score was a 6 out of 10. Not great, but that's what it was. And what I'm trying to do is find out how do my folks differ from my students, differ from the average, and that's this t-test. So this is the sample mean, this is the formula, and you'll find this in your textbook, minus the population mean divided by the standard deviation divided by the square root of n. So that's what it looks like. There's lots of other kinds of formulas that you'll see, and they all kind of boil down to this. So this is what you will either find listed in your statistical textbook, or you might find something slightly different. So what I've done here down at the left-hand side of the page is I've taken all these elements that are needed here, and I've put them down in this list, and then I'm going to figure out what they are. Now I'm looking here and I see that I need the sample mean minus the population mean. And so that turns into um, B23, that's the address of the sample mean, and B24 is the address of the population mean. So that goes in the denominator above the bar. And then below the bar, I need the standard deviation of this particular set. Now, what a standard deviation is it's like an average of how far every single one of these scores is from the actual mean. So a standard deviation formula would take the individual means and then minus it from the sample mean, that overall average, and they would get what's called a deviation score, and it would square that and do a whole bunch of other stuff. And we're not going to do that. We're just going to take the function that's available in Excel and find that standard deviation. So once again, you put the equal sign in, and then you do STDEV. That stands for standard deviation, and you can see that it tells you when you do this, calculates the standard deviation. We're going to name our range once again, B1 to B20, that's where our scores are, and that gives us the standard deviation of the distribution. So every one of these scores on average is about 2.54 in value away from the actual mean of the set of data. Now you also need, so that's B25, that's the address, it's in column B, row 25, so we know that's what stands in for this. Standard deviation, that lives in B25. Now we want to get the square root of n, and we know n is number 20, so we want to do equal SQRT, that stands for square root of the number, and we're going to also identify that by the cell it lives in, and it lives in column B, row 22, and we close that parenthesis, and that gives us the square root of 20. So the square root of 20 is 4.47. So now we know what we need to divide in the bottom half of this equation. Now there's a couple of ways to do that, and I'll show you that in a second. You can go here and you can take those numbers directly. So I'm going to say equals B23. Actually, we don't need just B23. If it's only a single cell, you don't need the parentheses, minus B24, and that's the top. And then underneath, let's stick a little bar there. Underneath, we know we have to take the standard deviation. So the top is 0.85, that's 6. 0.85, the sample mean, minus 6, the population mean. Now in the bottom, we want to have that standard deviation divided by the square root of n. So we go equals B25, that's where the standard deviation lives, and we're going to divide that by B26, which is the square root of n, and you'll see it's highlighted those for you. And then you hit enter, and there's your number. And now when you get down to the bottom to get the t-value, what you're actually doing is you are taking this value and you are dividing it by this value. And we're going to do the same thing that we did before. We're going to use the column and the row to identify that. So we're going to go over to t-value, and we're going to do equals H20 divided by H21. You can see they're highlighted over here, so you know you've got what you need, and then you hit enter, and that gives you your t-value. Now, we have set our alpha criterion. That's the point at which we're going to decide whether something is a significant difference or not, at 0.05. So if we come up with a t-value that is less than 0.05, or it's not significant. So that means our group didn't differ significantly from the population mean. They just kind of scored really right in that range. And if it's lower than, the p-value is lower than 0.05, then we're going to say, okay, so maybe that is significant. Now we know that 0.05 from the t table in your textbook, we know that 0.05 as a criterion value is a t-value of 2.093. So right now we know already that our t-test did not achieve significance because it's 1.497 or 1.5 if you round it all the way up. But we still want to know what that actual p-value is to kind of figure things out. And in order to do that, we need the t-value that we calculated, and then we need something called degrees of freedom. And degrees of freedom is usually the number of scores minus the number of groups that you're using. We only have one group that we're testing against a population mean, and we have 20 people. So we take 20 minus 1, and that gives us 19. Now to find the p-value, you can go out here to SocSciStatistics.com on their p-value calculator, and we'll go right there. There it is. This is a pretty nifty place, and this is also a place where you can calculate a number of different types of statistical tests. Here it is. Or make a bargram or a histogram creator or something like that. And this is a lot easier than using Excel stats on a super easier than so much easier than using SPSS if you're very new to statistics. So you just want to put your t-score in here, and we rounded that up to 1.5, and then we're going to put the degrees of freedom. Remember, that's 20 minus 1, and that's 19. And then we have a 1.5, we have a 0.05 criterion value, and we're doing it as a two-tailed, which means we could have had a really low score for our group, or we could have had a really high score. So it could have been in either direction. If we were only going to look for people that are, if our question is, did our group do better than the national average, then we would say one-tailed. But we just want to check and see how they did. Was it less well or was it much better? So we're doing a two-tail. And the actual p-value is 0.075, which is not significant at 0.05. So we're going to put 0.075 in our p-value. We're just going to put that over there. So now we have calculated the t. Now the thing that's nifty about doing this once for yourself is you get to see what all the parts of the calculation are, and you understand that what you're doing basically is looking at the difference between your group and the population group in the context of this data itself. The standard deviation, remember, gives us that average deviation from the sample mean, and the square root of n takes into account how many scores we actually have. So it's kind of good to do it this way the first time. Now, one thing you can do is you can check your work in vassrstats.net and see if it comes up with the same thing. And that gives you a little bit more information than you probably need, but it will give you that t-value. So one way to do that is to highlight this range from B1 to B20 and then do Control C to copy it. Then you go out to Vassrstats, which is my other favorite statistical place. You click on T-tests and procedures on the side. You click on single sample T-test, and you can see you can do all kinds of other stuff. And then you go down here to the data entry point and put your cursor in and do Control V to paste. Now all your data is there. You know that your population mean was 6 because your question gave you that. And then you click on calculate, and then it gets you your n and some other stuff you don't actually need at the moment. It gets the standard deviation and shows the sample mean, shows the difference between the two, gives you that t-value, calculates the degrees of freedom, and then it shows you what the one-tailed and the two-tailed p's are. So that's kind of interesting. Let me go back over here. This was a two-tailed. Yeah, here we are. Forgot to click calculate. So the two-tailed was 0.15. So let's fix that over here. Let me go down, and that's 0.15. See, there's a good reason to go and double check. And then we can go back and take a look at Vassrstats, and sure enough, the two-tailed is 0.15. So you can use Vassrstats calculations, or you can use the calculations on socialstatistics.com, the calculators, to get the information that you need. You could have done a single sample t-test here as well. However, I recommend that you do all of this yourself the first time. You figure out how to set up the actual formula on an Excel spreadsheet. Make sure you write it all out so you're not getting confused, and then follow the steps. And then remember that down here you want to write all the things that you need in order to finish the question, and then get your data put in here. Now, the other cool thing about this is when you have to show this to your faculty member as showing your work, you can just copy and paste this entire line, or you can even go out and show them what you used for the formula, and you can put this in a Word doc or something else to turn in. So that's a tutorial to show you how you can use Excel without knowing a whole lot about Excel, without having to install Excel stats, and without having to try and get through SPSS when you're just beginning to learn statistics. You can literally set it up here and get it done. And once you've done it once or twice, you can go out here to socialstatistics.com or vasterstats.net and use the calculators instead. And that's very easy to do. The only difference with those two sites is that you'll have to post the information from the statistical calculators back to your Word doc or your spreadsheet, because you won't be able to just copy and paste from the websites. So that's it. I hope that helps. Have fun.